Hi, I'm Nicole Borrelli, and I am a DPE at Google, and I'm going to talk to you about my imaginary legacy app with 10 pumps of Kotlin, and mostly to talk about Kotlin and Java interop. So yeah, let's get started. So, I mean, the reason that we're all here is because Kotlin is pretty awesome, right? But so we have our app and we want to write everything in Kotlin. But then there's like that million lines of Java programming language code there, and we're like, we want to rewrite it all, but that might not be the smartest approach. So when we at Google I/O, when we announced Kotlin as a supported language, we gave some advice for how you might go and have your tests and write your tests, or you might write new features and that sort of thing in Kotlin. And so we gave little bits of advice of you have send message or add listener. And we go through here and we're like, oh, this is great for Java, but if you're writing Kotlin, it would be even better if we had nullability annotations on these things, and if we have our single abstract methods and we put them as our last parameter. And so this is cool, and we might be cooking along in our app, adding new features, adding tests. And then we're like, but what if we wanted to do more where we want to call from the Java programming language into Kotlin? So here is where there's a bunch of little tricks that you can do. Britt talked about some of these yesterday, if you caught her talk. But yeah, I just wanted to go into some of these things. So let's imagine that we've got this utils class. I'm sure that no one has a class like this in their app, but I mean, if we did, it might look like this. And so let's say that we wanted to update this, and we're like, yeah, you know what? This looks much better as an extension function. So we're like, cool. So we write some code like this, and then the Kotlin compiler creates some bytecode that looks something like this. And we're like, cool, time since, and got the thing. And then you realize that in order to call this, though, because our class there is dates KT, and it's so we can go and we can use this JVM name annotation and change the name that the Kotlin compiler generates for this class. So now we can have utils, and we can use it just the same way. Not any sort of foreshadowing, but you could also use this JVM multi-class. And this way, if you have here we've got dates KT, and let's say that you had strings KT or something like that, you could have them all annotated with JVM name and JVM multi-class, and then the Kotlin compiler will put them all into one class file, and then from Kotlin, you use them just like you would normally use. From the Java programming language, they'll all be utils dot, and so you don't have to rewrite or refactor a bunch of code to get that. And yeah, so you can do stuff like this. So another fun thing with Kotlin are data classes. Because who really wants to write equals and hash code and that sort of thing? Much better to have something like this. But you write something like this, and the code that's generated looks great, but has getters and setters. And you're thinking, this is from Kotlin, you don't really mind because you can use the property accessor methods, and it's awesome. From the Java programming language, now you have to call get user, get text. And so one of the fun things we can do, of course, is we can annotate this with JVM field, and then you get the really nice accessing there as well. So a couple of things. So first, if you have a getter that's not actually a field, you can't just magically put JVM field on top of it and have it work. It just, there's nothing really that it can do to help you there. Another fun thing is that late inits are automatically exposed as fields, which was fun. And the last one is that if you have const values, they are also exposed as fields. You don't have to go through getters. So we took a look at that user there. So let's dive into that one a little bit more. So we've got this. We've got our user ID. We've got our name. We've got is verified, and we've got like spink, because these are important things we want to know about our users. And so we can look at the generated code. So here we've got get and set name, which seems reasonable. We've got is verified, taking off the Java Bean naming convention. It's a little bit different than the actual Java Bean naming convention, because if you have a property that is named is whatever, even if it's not Boolean, it will leave the name as is and won't prefix it with get. And then we've got get like spink and set like spink. But like I want to write my code where I can say if user.likespink. So I can go and I can annotate the getter, and I can change the getter with JVM name. And this is great. So now it will generate this like spink thing. So you might be asking yourself, okay, well, that's the getter. What if I want to change the setter? Well, same thing. So let's say instead of set name, we want to have change name. So again, just set. It's also possible if you don't, if the setters and getters are called out specifically. So if we had like var name string set value equals blah, 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 you can annotate the method itself directly with JVM name, no set or get in front of it, and change the name the same way. Yeah, and then we see we're generating that code. So, in singletons, yes, singletons. One of the interesting things to do with Kotlin is, being able to use objects to encapsulate a bunch of methods and functions and that sort of thing. And when we do this, we end up with a static final class repository, and we have an instance variable, and we have our lookup user as an instance method. Now, so from Kotlin, we just use repository dot lookup user. But from the Java programming language, you would have to use repository dot instance dot lookup user. If we didn't want to do that, because really, who wants to do that? We can annotate it with JVM static, and that will get this to create a static reference to this variable. Yeah, and then we can just use it like we would expect. Okay. So let's see. So we've got bitmaps, another little utility thing. This time we have our default arguments. And so, again, works perfect in Kotlin, but in Java programming language, when we try to access this, we'll get an error. We'll get saying that we're not passing in the value for the interpolator, even though there should be a default value for that. So we might go and we look at our generated code, and we see that there is this one resize method. And like if we dig a little bit further, we'll actually see further on in this class, we'll see that there is this second method there that looks suspiciously like we could use it. But if we go in, we'll see that it's actually a synthetic method. A synthetic method is a method that's generated by the compiler. We use in the Java programming language, synthetics are often used for accessing private members of inner classes, and the Kotlin compiler totally makes use of these. And so, since it's synthetic, we could cheat and we could call it the reflection, but it's got an ugly name and it's got ugly parameters, so we really don't want to do that. But we can use JVM overloads. And JVM overloads will create methods like resize, where it has just the two parameters. The JVM overloads will create one overload for each of the default parameters, and I think it's from left to right, basically. So if you have if you had 3 default parameters, it will generate the 4 different methods, but you can't mix and match like you could in Java. Like you can't use, because you can't put in named parameters, so you can't just skip the middle parameter. You'd have to put in the first of the second, the first, the second, and the third, but not the first and the third. But yeah, after we use JVM overloads, we get this. Of course, resize, like this works really well in Kotlin, right? It's a bitmap.resize, makes sense. But again, we might want to pop back over, check out JVM name, rename this, and then we have a much nicer name there. Yeah, so the last little thing that I wanted to talk about was checked exceptions. So here I've got my send message, and I want to call it from the Java programming language. And in Java, there's checked exceptions, and we like them. I mean, Kotlin chose a different way, but I mean, like, that's not all right. But so we want to do this, but because Kotlin doesn't have checked exceptions, it will give us an error here. But we can go through and we can say, Kotlin, I understand we're friends, but I really want to make my callers check for IO exception. And so you can say, throws IO exception, and it will generate the code to do this. And then our compiler will be happy. So, a quick summary of what we've talked about. So we have JVM name. JVM name can actually be used to rename basically anything that you want. Probably not a great idea to rename anything, but you could. If you just wanted that class named, Java is better, even though it's named Kotlin is better, you could. JVM field for exposing method or properties, which aren't backed by methods as fields. JVM static for exposing either methods or properties as static JVM overloads to get Kotlin to generate those overload methods for default parameters that you have, and throws for letting Java callers know that this method throws certain checked exceptions that could be checked for, that could be caught in your Java code. And yeah, thank you very much.